A few years ago, I sat on my BlackBerry. The screen bled into a colorful Rorschach test, and when I took it to the local wireless store, the sales representative was blunt. He told me they weren't allowed to fix phones in the shop, even though he wanted to, and that my only option was to pay $450 for a brand new replacement. Instead, I went home and spent $45 on a replacement screen and a small kit of specialized tools. Following a YouTube video, I pried the case open, unscrewed the internal components, and swapped the screen myself. The entire process took 10 minutes. That same year, 17-year-old George Hotz used a guitar pick and a soldering iron to do something much larger. By erasing the baseband processor chip, he manually bypassed the digital locks Apple and AT&T had spent millions to install, becoming the first person to unlock the iPhone. But we see a different outcome when the systems get larger. During the Deepwater Horizon spill in 2010, massive task forces of corporate engineers and government specialists spent months trying to activate 450-ton safety valves and deploy deep-sea robots. They were the world's leading experts, yet the oil continued to flow for nearly 3 months. There is a disconnect here between scale and agility. The same protocols and structures that allow large organizations to manage massive projects also make them rigid. In these moments, the individual tinkerer, moving without the weight of a bureaucracy, can often find a path through a problem that a billion-dollar system hasn't even finished analyzing. To tinker isn't to wander aimlessly. It is a specific mindset based on recombination. A tinkerer takes existing tools and technologies and combines them in ways the original manufacturers never intended, often without a strict end goal, simply to see what the materials can do. But we are increasingly moving away from this chaotic exploration. Our educational and corporate systems prioritize specialized experts and standardized roles, which turns the rest of us into passive consumers rather than active makers. This shift carries a warning. When a culture moves from being a nation of doers to a nation of consumers and speculators, its economic engine changes. Instead of discovering new ways to create value, the focus shifts to simply betting on what already exists. This do-it-yourself spirit is built into the American origin story. George Washington, for example, spent much of his life as an agricultural tinkerer. He refused to follow the farming methods of his father's generation, instead running hundreds of experiments on crop rotation and fertilizers to find a better way to manage his land. When Washington tried to build the Potomac Canal, he couldn't find a single civil engineer in the colonies to help him. Rather than waiting for an expert from Europe, he hired James Rumsey, a local innkeeper who had built a mechanical boat model. Together, they used raw trial and error to figure out how to blast through rock and move water. Even Thomas Edison, often cast as the ultimate industrialist, was at his heart a messy and disorganized tinkerer. When he invented the phonograph, his investors demanded a finished product they could sell. But Edison wasn't a businessman. He was an inventor who wanted to continue experimenting with steam power and clock springs. He ignored the commercial timelines of his backers to keep playing with the mechanics.
This creates a natural friction. Corporate systems require order, measurable output, and predictable growth. But the tinkerer requires an environment that allows for failure and unstructured time, the very things a modern office is designed to eliminate. Tinkering isn't just about gadgets, it's how we build systems. In the 1920s, Thomas McDonald designed the U.S. highway network not through a top-down federal mandate, but by tinkering with organizations. He brought together bike advocates, cement makers, and local leaders into a decentralized web of cooperation that the government couldn't have built alone. Modern inventors like Dean Kamen follow a similar path. He argues innovation rarely comes from new scientific discoveries, but from recombining what we already have. When Kamen built the first portable dialysis machine, or the Segway, he didn't invent new physics. He used existing parts, like printer motors and gyroscopic sensors, and integrated them into new systems. To Kamen, this is true wealth, the creation of new capabilities. It stands in contrast to what he calls fake wealth, which is just the act of moving existing money from one person to another through accounting or legal maneuvering. We saw the limit of fake wealth during the 2008 financial crisis. Thousands of highly trained experts used complex financial engineering to move massive amounts of money, but they produced no new technology, and they solved absolutely no real physical problems.
Progress depends on this act of taking physical things and recombining them into something new. It's a messy, tangible process that thrives on the very disorder that rigid financial and corporate systems are often built to avoid. But today, the entry point for tinkering is moving further away. Devices have become too complex and components too microscopic for a teenager to simply open the hood. This complexity has a ripple effect. Engineering graduation rates have struggled to keep pace, and many corporations have closed their open research labs, folding their creative minds into standardized management roles where innovation is tied to a strict schedule. When technology is locked behind a black box that we aren't allowed to open, it trains a society to be passive. Instead of seeing a broken device as a puzzle to solve, we see it as a product that must be replaced by an expert. However, the instinct to build hasn't died. It has simply evolved. The tinkerer has moved into the maker movement. New tools like 3D printers, Arduino circuit boards, and local hackerspaces are democratizing engineering. They allow anyone to experiment with complex electronics without needing a corporate laboratory or a massive budget. Dean Kamen's first robotics program is a prime example. Every year, thousands of high school students build robots and perform experiments that would have been Nobel-level work just 2 decades ago. These students aren't following a corporate manual. They're soldering, breaking, and rebuilding their own designs. In this environment, the chaotic process of building and failing is the point. Surviving the modern era requires us to look past polished, finished products. We have to defend the messy, unstructured spaces where true wealth is invented, one broken part at a time.